Welcome back. Let's continue with part C of chapter 3. So what we're going to do on this one, as I mentioned before, we talk about so many different things about energy. So on this part, we're going to talk about the different type of energy. And let's start with a vision of our universe. Our universe is immense, and at least in what is related to chemistry, the main two components of the universe are going to be matter and energy. And we talk already about matter. We classify matter, we talk about atoms, molecules, mixtures, and so on. So the other component of the universe, at least in relation to chemistry, is energy. And we're going to see that energy is nothing more than the capacity to produce work. So what do we mean with that? If you can do work, then that's energy. So they go hand on hand. It's kind of a cyclic definition. And what is work? Work is nothing more than by applying energy, causing something to move. For example, if I move the pencil that I have on my hands right now, I had to apply energy to do that. The pencil did move, so that was work. If I have to move my mouth to speak, I had to apply energy to do that, and my mouth did move, so that was work. So energy relates to work in that sense. Energy is what produces work. And we're going to see in relation to energy and matter, the energy is going to be expressed mainly in the forms of kinetic energy and potential energy. Kinetic energy is going to be the energy of movement, while potential energy is the energy that is stored. For example, if you go to the lake and there's a dam in there, all that water that is being retained by the dam is holding potential energy. It can fall at any time with a lot of force. And once it does that, it's transforming from potential energy to kinetic energy. The same way that if I go up a set of stairs, I have to apply kinetic energy, and once I get to the top, then I have a lot of energy stored there. If I walk over the edge, then I will start moving really fast. And I go from potential to kinetic. So it's always a conversion between kinetic and potential energy. In terms of chemistry, the molecules, the bonds that keep the molecules together, we consider that potential energy. For example, the bonds that keep together all the nutrients on a banana, if I eat it, I'm eating energy because it was stored in the banana. So any energy that is stored is what we call potential energy. Energy that is in movement, we call that kinetic energy. Or when something is moving, we say that it has kinetic energy. So all the energy of chemicals is either potential or kinetic or a combination of both. So let's look at some examples here. So let's say, imagine that the baby is playing with that dog, and that dog have brand new batteries, and he turn it on, and what is he doing? He's holding it, right? So at that moment, does that dog has kinetic or potential energy? What happens if he releases really fast? It starts moving right away. So at that moment, the dog have a lot of potential energy because it's being held on place, is storing that energy. The lady on the desk, what can we say about her? Well, she's moving her mouth, most likely. She's talking on the phone, right? So that's kinetic energy. She's spending energy there. She's definitely thinking. So there's a lot of energy being used by her brain to process all that. And there's a lot of movement of, we're going to talk about electrons in chapter 4. There's a lot of movement of electrons and molecules for a person to be able to think. the young group here of volunteers, they are not doing anything right now with those spades or shovels, but very soon they're going to be doing that, and that's going to be kinetic energy. The guy using the tool, definitely kinetic energy. We assume that he's moving the tool back and forth. The lady going up the stairs, as long as she's moving, that's kinetic energy. The moment she gets to the top of the stair or she stops whenever that is not the ground, she have accumulated potential energy. And if she jumps, she's gonna go really fast because all that energy is gonna come back. What about the mom and the baby here? The baby was on the floor. She lifted him or her up, and now the baby has potential energy. If she suddenly removes her legs, that baby is coming down with a lot of energy, the energy that was stored. So stored energy is potential energy. Energy of movement is kinetic energy. So we can go a little bit deeper with kinetic and potential energy. And mainly kinetic energy, which is the energy of movement, we can see that reflected as electrical energy or thermal energy. On chapter 4, we're going to learn about the atoms containing electrons, and the electrons are always moving, and electricity is nothing more than the movement of electrons or electric charges. So the movement of those electrons are going to produce electrical energy. What about thermal energy? If you have already looked into the discussion for this week, it shows you how the thermometer works. And the thermometer works by no other means that the liquid on the thermometer is made out of molecules, the glass of the thermometer is made out of molecules, the air is made out of molecules, and if those particles are moving, they're hitting each other, they're transferring their energy, and when the mercury on the thermometer expands, that means that the molecules are getting away from each other, and that causes the thermometer, the mercury on the thermometer to go up or down. So make sure you see that on the discussion board on the video that is posted there. So thermal energy, or the energy of heat, which is the one we are going to concentrate, is due definitely because of the movement of electrons and the energy that they transfer to each other. And by the way, every time I say heat from now on, I can also say Q. So the letter Q is going to represent heat, which is representing thermal energy. So daily word 3.6. What is the definition of energy? What is the law of conservation of energy? I didn't tell you that one, so I'm going to tell you now. The law of conservation of energy is very similar to the law of conservation of mass. Energy cannot be destroyed. Energy cannot be created. It can only be transferred. And explain the difference between kinetic energy and potential energy. Moving on, we're going to say that we have been exposed to different forms of energy. We talk about kinetic energy. We talk about potential energy. We saw that kinetic energy can be translated into electrical or thermal energy. We saw how kinetic energy and potential energy interconvert from each other. And we saw that the main component of the universe, at least in reference to chemistry, is matter and energy. So now that we understand those concepts, as scientists, scientific method, right? We have to measure something to be able to do experiments. So how do we measure energy? So it's going to be several units to measure energy. And here they are. The main ones we're going to study, the ones adopted by the metric system, are going to be the calorie with lower C, and the calorie with a capital C. Notice that the calorie with the capital C is nothing more than 1,000 lower C calories. So a calorie with a capital C is the same as a kilo calorie, 1,000 calories, right? Then we have the joule. If you go to the stores in Europe, where they only use the metric system, you're gonna see that all the food is labeled not in calories but in joules. So to convert from calories to joule, we have the equality. 1 calorie, lowercase calorie, equals 4.184 joules. So those are equalities, right? So we can do, as you already know, we can do conversion factor with those. And that's what we're going to do with this problem. Given 947.5 kilojoules, can you find the calories, lowercase calories? And the answer is yes. Since I know how to use the train track method, I can do any problem. It doesn't matter what units you're talking about, because all I have to do is cancel the one I do not want and find the one I want. And then I say, can I relate calories and kilojoules? And I'm going to look at my table. So I got calories and joules, capital C and kilocalories. So I do not have anything that relates lowercase c with kilojoules. So what I'm going to do is I'm going to take the kilojoules first, and I'm going to convert that to joules first, because that's what I can use, right? Calories and joules. So let me get rid of the kilojoules, because I want the joules. The one with the prefix is kilojoules, so that one gets the 1. And kilo means 10 to the third. And we learned that on a previous lecture. So that gets rid of the kilojoules. So now I have the joules, but I don't want the joules because I'm looking for calories. And I'm going to get rid of the joules. And according to my table, 1 calorie equals 4.184 joules. So if I want to find the answer to this, I just do 947.5 multiplied by 10 to the third divided by 4.184 joules. So nothing more, nothing new, same thing we had done before. Now we have a new set of units. So this will be your daily work. So first one, you're going from joules to calories. So that's right there, joules to calories. Second one, you're going from calories to joules. If you can do it one way, you can do it backwards, right? Then you're going to do kilojoules to calories. That may involve 2 steps. Calories to kilojoules. That may involve also 2 steps. And then calories, and then calories lowercase c to calories uppercase c, which is nothing more than this one here. And that should allow you to complete your daily work. And here's another one. This one is a little bit more complicated, but you can do it. I'm even giving you the answer, so all you have to figure out is how you get to that answer. Set up, use the train track. It could be multiple steps, multiple steps, and come up with 48 bags. And you will see, yeah, you know how to do this. Very soon we're going to start talking about chemical equations and molarity and stuff like that, and we're going to be doing multiple conversions. So with that, I would say that at least you have been exposed to the different type of energy units. And as long as you have the table, as long as you have a table like that, you should be able to figure out how to use the train track with those tables. So the last thing we have on this recording is distinguish between exothermic and endothermic. So I mentioned to you earlier that we're talking about thermal energy, which is heat, and when we use heat, we're going to be using the letter Q. So if we're talking about anything thermal, we're talking about heat, and we're going to use the letter Q for that. So exothermic is something that releases energy, and we're going to represent that like minus Q. That means the heat is being released. So it's releasing energy in the form of heat. So endothermic is the opposite. Endothermic is a process. It could be a physical process or a chemical process. It's a process that absorbs energy. So let's see how we're going to understand that. So I got about five examples in here. So let's see how we're going to do this in terms of exothermic and endothermic. So let's look at the first one. So let's call this number one. So I imagine all of you have probably seen one of these ice cold packs. Basically, if you are feeling pain on your muscles, you activate one of those and you put it on your muscle to release it, to release the pain. So it tells you to squeeze together here. So what you're doing there is you're breaking some type of container and mixing chemicals. So this is actually a chemical change. So this will be a chemical change. The question is, would it be a chemical change exothermic or endothermic? How is the energy being exchanged? Well, you're going to have to think about what happens. When you activate one of those and you put it on your skin, does your skin get hot or does your skin get cold? So think about that. If I take one of those ice packs and I activate it and I put it against my skin, what do I feel? But you're going to feel that your skin gets cold, right? That's what is called a cold pack. So does that mean that your skin is gaining or losing energy? What do you think? If you're standing in front of a fireplace, the fireplace is giving you heat, right? So in that particular case, you're absorbing energy and you feel hot, right? So in this case, if you're feeling cold, it's because you're losing energy. And that energy is going somewhere. You're not just losing energy, right? That energy is going to the cold pack. So whatever is happening on the cold pack is taking energy. So therefore, this is a endothermic process. So that's the way you have to think about this. What is my brain telling me? My brain is telling me I'm getting cold. Getting cold means losing energy. And if you're not sure, just think about the fireplace. The fireplace makes you hot, right? So you're getting heat. So if you're feeling cold, it's because you're losing heat. But the heat doesn't just flies everywhere. The heat is always transferred from a hot body to a cold body, or hotter to colder. So there's always the heat is energy that moves from a hotter body to a colder body. So if you're feeling cold, it's because your energy is going to the cold pack. So whatever is happening on the cold pack, that chemical change is an endo process. What about number two? Number two, you have a piece of ice on your hand, and you probably experienced this last week. So if you take a piece of ice on your hands, how does your hand feel? And your hand is going to feel cold, right? What is your hand doing? Gaining or losing energy? I feel cold, so it's losing energy. What is the ice doing? The ice is taking that energy from you. And therefore, it's going to start melting. So this is melting. So that ice is going to become water. I can take that water and make it back into ice if I have everything I need, right? So this is a physical change that happens to be also endothermic. And it's only endothermic if I'm thinking about the ice. So the ice is taking heat. But what if I'm thinking about my hand? Then it would be exothermic because my hand is losing heat. So that's what we call the system. Whatever we are looking at, whatever we are observing, we call that the system. Everything else around is the surrounding, right? So on this particular case, on case number 2, if the system is my hand, then the ice is the surrounding. And I'm looking at the system always. So if I say that the system is my hand, then this will be a exothermic process because my hand is losing heat. If I say that the system is the ice, then it's an endothermic process because the ice is absorbing heat. Let's call this one number 3. So opposite to number 1, this is a warmer, a hand warmer, which means when I break whatever is inside and the reaction begins, so this is going to be a chemical change. There's going to be a reaction happening. And that reaction is going to make my hand feel hotter. If my hand is feeling hotter, it's because my hand is absorbing heat. But if I'm thinking about the warmer, then that's my system. So in terms of the warmer, this would be a exothermic process because the pack is releasing heat. What about number 4? Number 4 is just a suggestion. So I suggest that you think about what happens when you're on your car, assuming it's not an electric car, and you push the engine start-stop button. If you do that and if the car is totally off and you do that, your engine will start. And you have a combustion engine, which basically means you started with a spark, and that spark is burning your gasoline now. So that gasoline is undergoing a chemical reaction. So that's a chemical change. And that chemical change is producing a lot of heat. And if you don't believe me, after several minutes, go touch the hood of your car or go stand behind the tailpipe. So heat is going to be coming out of your car. So therefore, if the engine is my system, then the engine is releasing heat. So this will be a exothermic process. And the last one, what you see here is dry ice, which is just solid carbon dioxide. It was thrown into the water and it began absorbing the heat from the water. So the water is giving the heat to the dry ice, but the water is touching the air, right? So the water is taking the heat from the air. So because it's taking the heat from the air, the water vapor molecules are gonna start losing their kinetic energy. They're gonna come together, and from water vapor, they're gonna start coming together to make what ultimately is gonna be a liquid water. For in the process, they create the fog that you see. So the dry ice taking the heat from the surrounding, that's going to be a endo process. The surrounding giving the heat to the dry ice, that's going to be a exo process. So endo and exo always go hand in hand. Something has to be colder, something has to be hotter. It's always traveling from hot to cold. So one of those two things there is suffering an exothermic process, while the other one is undergoing an endothermic process. And the last one, I just put that in there, this one here. The only reason I put that in there is because that is a reaction you're going to be doing this week on your lab. And I want you to think about it when you do that. I want you to think about endo and exo and try to determine if you can say, oh, that was an exothermic reaction, or no, that was an endothermic reaction. So based on what you know about what your brain tells you that you're feeling, decide when you see that on the lab if it's exo or endo. And that's your daily work 3.9. 2 questions. Classify, you got 3 processes, classify them as either exo or endo, and then explain how you reach that decision about the way we're thinking. Oh, my brain is telling me my hand is getting cold. That means my hand is losing heat. Therefore, blah, 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 blah. So make sure that you can explain why. And with that, I would say that we talk about the energy. So we can recognize different types of energy: kinetic, potential, electrical, thermal, and so on. You saw the table we can use to convert between different units of energy. You know that we measure energy in either calories or joules, but it could be kilocalories or capital C calories, or it could be joules or kilojoules. And we just talk about processes, either chemical reactions, chemical changes, or physical changes like melting, boiling, and so on. We can talk about those in terms of being endo or exo processes. So when we come back on part D, we will talk about how to measure the heat with a thermometer and the different units that we use, and we're gonna see how we can relate that to what energy does. And be thinking about this in preparation for that. If I send you in the middle of July in Texas, I put a piece of wood on your driveway and a piece of metal on your driveway. And I tell you, I'm going to give you $10 to bring me one of those in after they have been on the sun for about 3 hours. Which one would you grab and bring to me, and why would you do that? And that will explain a lot of the concept we're going to do. So that's it for right now. So next time I see you, we will move into part D of matter and energy. Have a great day.